Hello students, in this video I will go through exercise U3A08B where I will be applying triangle inequality theorem as well as some concepts related to exterior angle theorem. Alright, let's take a look. Use the exterior angle theorem to list all of the angles that satisfy the stated condition. Measures less than angle 4. So I need to look for all the angles that are going to be less than angle 4. And this is not going to be based on, just ballparking or eyeballing which angles are less than angle 4, because that's not really the point. The point is to exercise the concept that the sum will always be greater than its parts, right? Or the parts will always be less than its sums, okay? So angle 4 here, I immediately notice, okay, is outside of the triangle. It's outside of this triangle over here that I'm shading in, right? And angle 4 will therefore be equal to angle 1 plus angle 2. And no, I'm not saying 1 plus 2 is equal to 4. I'm saying the measure of angle 1 and the measure of angle 2 will add up equaling to the measure of angle 4. So because of this, angles 1 and 2 will be less than angle 4. And the reason for this is the sum will always be greater than its parts, or the parts will always be less than its sums. And then we can apply the very similar concept with angle 5. So angle 5, which is over here, is exterior to that triangle there. And again, by the same logic, angle 5 is going to equal to angle 7 plus angle 8. And therefore, angle 5 will be greater than 7 and 8, or angle 7 or angle 8 will be less than angle 5. Angle 9 will equal to angle 6 and angle 7. And therefore, we can say that angle 6 and angle 7 will be less than angle 9. However, angle 9 is exterior to this angle. That is true. But it's also exterior to this entire triangle. So this question here is a little trickier. So not only is angle 9 equal to angle 6 plus angle 7, it's also equivalent to angle 1 plus angle 3 and angle 6. So not only is it greater than 6 and 7, but it's also greater than 1 and 3. I'm sorry, 1 and 2. What am I saying? No, 1 and 3. I meant 1 and 3. I wrote 3. I was looking at 2. But, okay. So, angle 9 is going to be greater than 6, 7, 1, and 3. Okay. So, let's move on to the next one. Angles greater than angle 8. So angle 8 is over here. Which angles are going to be greater than that? So I know that 8 plus 6 will equal to 2, right? Angle 8 plus angle 6 will equal to angle 2. So therefore, angle 2 must be greater than angle 8. Are there any other angles? I know that angle 8 plus angle 7 will equal to angle 5. So therefore, angle 5 will also be greater than angle 8. Let's take a look at angle 7, angles that are greater than angle 7. So I know that angle 7 plus angle 8, one more time, will equal to angle 5. So therefore, I know definitively that angle 5 will also be greater than angle 7. Are there any other angles that are going to be greater than angle 7? I don't believe so. I know that 7 is equal to 1 plus 3. No, I believe that's it. Yeah, so angle 5 is the only one that I can see here. But if you guys find some other ones, do let me know. Number 14. List the angles and sides of each triangle in order from smallest to greatest. So the side lengths, okay, will always be listed, will always be in the same order, ascending order as the angle measures, right? So if I list out the smallest angles first, okay, or actually before I list out the angles, because this triangle here is a special triangle. Why is it special? Because this is a right triangle. WY, okay, will always be the largest side in a right triangle, because the hypotenuse will always be the longest side in a right triangle. So therefore, WY will always be the longest. Here I'm asked to list the angles and sides. So I'm going to give myself a little room here. So side WY is also side Z, right? Lowercase z. That's the longest. What's the second longest? Well, they gave us some numbers here. The second longest is 3.4, so that's side Y. And then which side is the shortest? Well, that has to be then side W. Which angles are going to be the smallest? So angle W will be smallest, followed by angle Y, followed by angle Z. Okay. All right. So here I'm told the side lengths. So the side lengths are 4, 5, and 7. So I know that the shortest side, therefore, is side S, followed by side 5, which is side T, followed by side R. So then angle S is going to be the largest. This is going to be the smallest, followed by angle T, followed by angle R. Here I'm told the angle measures, so I'm going to list the angle measures from smallest to largest. So that would be angle H, followed by angle J, followed by angle K. So therefore, the shortest side will be lowercase h, followed by lowercase j, followed by lowercase k. The sides and angles all have to correspond. The smallest angle and the shortest side, they are opposite of one another. Okay, and then there was number 17. So the smallest angle is 49, so that's angle L, followed by angle P, followed by angle M. So the shortest side will be side L, followed by side P, followed by side M. I'm told two of the three angles. I can definitely find out what the third one is. So the two added up together is 122. The leftover will be 58 degrees. So knowing this, angle A will be the smallest, followed by angle B, followed by angle C. So therefore, side A will be shorter, then side B will be shorter than side C. This is a 90-degree angle. This is 46, so therefore this must be 44 degrees. So therefore, I know that angle C will be followed by angle D, will be followed by angle E. And again, side length C is shorter than side length D, which is shorter than side length E, which is the hypotenuse. Again, going by the same logic as before, the hypotenuse is always going to be the longest side of the triangle. Okay. Question number 22. List the angles and sides of each triangle in order from smallest to largest. So in this case, let's solve for, well, I already know what the largest angle is going to be. It's just a matter of now figuring out what the other two are. So I know that these two must add up to 90 degrees because I already have 190 over there, right? So 2x plus 1 plus 2x plus 9, they should add up to 90. So therefore 4x plus 10 should equal to 90. Subtract 10, 4x is equal to 80. Divide by 4, x is equal to 20. So since x is equal to 20, angle x will therefore equal to 41. Angle y will be 49. So now I know the angles in size order. It says list the angles and sides of each triangle in order from smallest to largest. So I have angle x, followed by angle y, followed by angle z. So therefore, the shortest side will be x, followed by y, followed by z. Okay, so I'm not told the exact angle measure, but I am given clues about the angle measures. So I know that 2x plus 3, add it with x minus 1, add it with x plus 6, should add up to 180 degrees. So if I combine like terms, I see I have 4x, and plus 8 is equal to 180. Minus 8, I get 4x is equal to 172. Divide both sides by 4, I end up with 43 as x. So if 43 is x, then that means I have here 89. And over here is equal to 49. And lastly, over here is 42. So therefore, the smallest angle is P, followed by Q, followed by M. The shortest side would be P, followed by Q, followed by side length M. Let's take a look at this guy. So the instructions here says use the figure at the right to determine which, and it got cut off. Okay, so let me see here. What exactly is the instruction here saying? Let me see, and then I'll correct it on the actual file. Let me see. So the question is asking for us to okay. The question is asking for us to determine which angle has the greatest measure. So I need to figure out between angle 1, 5, and 6, which angle is going to be the greatest measure. Okay, so that's easy enough. So angle 1 and angle 5 and angle 6. So let's see here. 1, 5, and 6. So I have 1, 5, and 6. Since angle 1 is the exterior angle, and 5 and 6 are the two interior angles, immediately I know that angle 1 will be the largest, so I'm just going to circle it. Angle 2 and angle 2, 4, and 6. So 2 was on the outside, 4 and 6 are on the inside. So of course angle 2 is going to be the largest because angle 2 is equal to 4 plus 6. And you know what? I'll just write this out. Angle 1 is equal to 5 plus 6. Angle 2 is equal to angle 4 plus 6. And then the next one I have 7, 4, 5. Let's see here. 7, 4, and 5. 7, 4, and 5. 7 is on the outside, 4 and 5 is on the inside. So 7 is equal to 4 plus 5. So of course angle 7 is going to be the largest. Next one is 3, 11, and 12. So looking at this, 3, 11, and 12. Where are you? 3. So I see 11, 12, and 3. There you go. So angle 3 is again going to be the largest. I hope they don't just list always the first angle there for all of these, because that would be a really boring problem set. Angle 3, 9, and 14. Let's see here. 3, 9, and 14. 3, 9, and 14. Yes, it is angle 3 again. Because, well, angle 3 is equal to angle 9 plus angle 14 plus angle 11. So therefore, all three of those are going to be less than angle 3. Next, I have angle 8, angle 10, and angle 11. Let's see, where's angle 8, 10, and 11? So I see 10 and 11. Where is 8? 8 is located over here. So of course, angle 8 is going to be the largest because angle 8 is equal to angle 10, 11, and 14. Okay, moving on. Using the figure on the right, determine the relationship between the measures of the given angles. So when it says determine the relationship, I'm going to determine which one is greater or which one is smaller. So ABD is this angle over here. BDA is this angle over here. Seeing that BDA is opposite of side 3 and angle ABD is opposite side 13, I can tell which angle is going to be greater. Angle ABD is going to be greater than angle BDA. And then I have BCF. Let's see here. BCF. So it's this angle over here. And angle CFB. CFB is this angle over here. So if I compare that, side 14 is going to be larger than side 14 is smaller than side 15. So therefore I can say that BCF is going to be larger than CFB. Okay. And then BFD is this angle over here. BDF is this angle over here. So 15 is going to be larger than 12, so BDF is going to be larger than BFD. And then I have DBF. Let's see here. DBF is this angle over here. And BFD is this angle over here. So which one is going to be larger? So 12 is definitely larger than 5, so BFD is going to be larger than angle DBF. All right, moving on. Use the figure at the right to determine the relationship between the lengths of the given sides, SM and MR. So this is really going opposite of what we just accomplished in the past 4 examples there. So I have SM and MR. So SM and MR. So SM is opposite of 60. MR is opposite of 70 because 70 and 110 makes 180. So therefore I know that SM is going to be longer than MR. Okay, moving on. RP versus MP. RP versus MP. RP versus MP. Again, do not go by just how the diagram looks because that defeats the purpose of learning a new theorem. So if this is 60 and this is 85, the two together, that makes 145, leaving me with just 35 over there. So 35 is smaller than 70, so therefore PR or RP is going to be longer than MP. Okay, and moving on, I have RQ and PQ. So RQ and PQ. RQ and PQ. So I have 85 and 30. So 85 is definitely larger than 30. So therefore, PQ is going to be larger or longer than RQ. Lastly, SM and RQ. SM and RQ. SM is this guy right here, and RQ. SM and RQ. SM and RQ. We got to compare those sides now. SM and RQ. SM and RQ. I don't think that we can make any kind of conclusive statements here because they are not of the same triangle, SM and RQ. So this is inconclusive because they are not of the same triangle. We cannot make a comparison if they are not of the same triangle. I think this is actually a typo on the author's part. This problem set came out of the Glencoe textbook, so this one's actually inconclusive because sides are not of the same triangle. Okay, and question number 41. List the side lengths of the triangles in the figure from shortest to longest. Explain your reasoning. So according to this, 6271, that's a 133, leaving me with 47 over here. And then I have 83 and 42 adds up to 125, leaving me with 55 over here. If I have 10, so it says here, list the side lengths of the triangles in the figure from shortest to longest. Okay, so that means 47, okay, if I look at the triangle, if I call this triangle 1 and call this triangle 2, that means I have AB is the shortest, followed by 62, which is BC, followed by 71, which is AC. And if I look at triangle number 2, the shortest side is going to be 42, which is BC, followed by 55, which is CD, followed by BD. And looking at this, CD is going to be greater than AC because 12 is greater than 2. So because of this, I can then make the following conclusion, that AB is less than BC, is less than AC, is less than CD, is less than BD. Yes, that's it.